Exactly, said Denicky, but the problem comes towards the end of the landfill's life. At some point, the amount of organic material still producing methane starts to drop, and it gets to the point where it is no longer cost-effective to capture. At that point, the economics deter us from doing any further mitigation, but the landfill is still producing volumes that pose a serious danger to our environment through global warming. So I and my team have developed these plastic lattices impregnated with methanotrophic microbes that we can place on top of the landfill to degrade the remaining methane into CO2 and water and biomass as it comes out until there's no more methane to degrade. After half a decade of working with methanogens to make methane, this was the first I had heard of harnessing methanotrophs that eat methane. And it turns out they aren't exotic or hard to come by at all. Methanotrophs live everywhere in natural ecosystems. Wikipedia tells us, quote, methanotrophs, sometimes called methanophils or methanophiles, are prokaryotes that metabolize methane as their source of carbon and energy. They can be either bacteria or archaea and can grow aerobically or anaerobically and require single carbon compounds to survive. So it turns out that this is a rather general strategy among two of life's 5 kingdoms. How hopeful is that? It further tells us, quote, methanotrophs are especially common in or near environments where methane is produced, although some methanotrophs can oxidize atmospheric methane. Their habitats include wetlands, soils, marshes, rice paddies, landfills, aquatic systems, lakes, oceans, streams, and more. The more can include presence in the air and clouds, and this is currently under investigation with promising results. As stated in the article, viable methanotrophic bacteria enriched from air and rain can oxidize methane at cloud-like conditions in Aerobiologia, Volume 29, pages 373 to 384. The authors of that study say, we demonstrate here for the first time that viable methanotrophic bacteria are present in air and rain, and thus expand our knowledge on the global distribution of methanotrophs to include the atmosphere. The fact that they can degrade methane to below atmospheric concentrations when inoculated into artificial cloud water leads to an important possible effect of these organisms. The atmosphere may not only function as a medium for microbial dissemination, but also as a site of active microbial methane turnover. So perhaps biogenic methane isn't such a worry after all. Does that mean we don't have to worry about cows at all?